Let's go and do 2.3. We'll get started. Describing sets as unions or intersections. So this is the lesson where I kind of planned for us to see those interesting symbols, which, again, it's nice to write things in shorthand. It does get to the point where it's like if you really like that stuff, that you've crossed over the line of big-time nerdiness, and you start understanding things that you never understood before. I felt good about it, but looking back, I realized that maybe I shouldn't have. That doesn't mean you shouldn't, by the way. You can decide for yourself. A set is just a bunch of stuff. Now, this being a math class means that when we say a set, we're looking at a set of numbers, right? And so, see that fancy art? That's what I was talking about right there. When I write it out, I just do 2 lines like this and then an R. If I really want to go super fancy, then I'll make a little swoop like that. Although my handwriting seems to suck pretty bad, so that people don't really think it's that fancy either way. I'll take it. Math people call the stuff in the set elements, and that's where that one symbol comes up. We'll talk about that here. Stuff or elements are not listed more than once in a set. So even if it repeats, something that repeats, this will be important later on, by the way, but because we're going to look at lots of different types of sets. But yeah, we never list them more than once, okay? So these symbols here, R is real numbers, Q, really that should be an I for integers. No. That's rational numbers. There we go. Rational numbers, that's an R. That's right. The Z is an I, that's for integers, W is for whole numbers, and N is for natural numbers, numbers that occur in nature. So there we go. Set notation or set builder notation. See, there it is. X is something you wear that starts with S. Socks, shirts, smocks, sandals. There we go. That's my list right there. Shoes, suspenders. If there's more than that, which I could be off. I just don't really care, and I don't want to list more than that. Plus, it won't fit in the slide. But this is just the list method, which is, for me, I think it's the most common method we use in this class. But like you said, we have seen the set builder notation, which kind of looks like this. But it's more generalized. See that? So shoes, shirts, sandals, socks, smocks, and suspenders. Those are things that you wear that start with S. But yeah, set notation is more of a general format for those, so that you don't actually have to list all the values or whatever's in the set. Now, those aren't numbers. Yeah, it's okay. A set can be non-numerical if we want it to be. And it can do that not only with the list method or roster method, but also the set notation like that, okay? Oh yeah, so fancy brackets. I should point this out because if you don't use fancy brackets in your sets for the exam, which our first exam is after Module 2, right? Then I actually have to take points away. I don't have any control over that, sorry. But here's how if you want to make your brackets super fancy, and you can practice them over and over and over like you would with cursive, but to open up a set of fancy brackets here, you just do an S and then a 2, boom. Well, that's not super fancy though, Sal. It's about as fancy as we need it to be. Well, if you want to close that, just do a 2 and then an S. See that right there? Boom. I think that second one turned out pretty fancy if you ask me, but that's just me. You will have to use these, even though I haven't seen the exam, you'll have to use these on the exam. Of course, if it was on the computer, you just type it in and be done. Example of a set. C is a set of things you wear that start with S. So those 2 sets we could have said it is set C. Maybe set S would be more appropriate. But it's possible to have an empty set, which, see the brackets right there? It's just empty. It just has nothing in between it. Why do we have the brackets there at all then? Well, I don't know. I mean, they are fancy after all. You could use this symbol right here that indicates that a set is empty. So like if C were, let's use a different letter, right? Like B. B is the empty set. All right, B is the empty set. Something like that. Okay? So to indicate that an element is part of a set, we use this symbol, which, again, mathematically, this would read as is an element of. If you put a line through it like this, it means it's not an element of whatever set it is that we're looking at, okay? So, again, this is just a nice shorthand way to write this with symbols. And if you can understand that, you can understand how math becomes super manipulative if you want to use it for evil purposes, right? So 5 is an element of set G. That's this. That's exactly how that reads. Math people would look at that and say 5 is an element of G. Again, I think that's kind of nerdy, but it makes me feel good inside for some reason. So if we said negative 10 is not an element of set W, that's how we would write it mathematically speaking, okay? Why would you do that? Well, I mean, it makes so we don't have to write so many words, but it also makes us feel smarter than we probably are sometimes. And if you want to encode it a certain way, then you can as well. But there's the decoder. Here are three sets, A, B, and C. Oh, that's nice. A is a burger and fry, B is salami, and C is slamia. I don't know where that came from, but you may notice on this that the order of the value, and remember I said we don't list them twice, dang it the heck, but whatever, okay? So SALAMI, SLAMIA, they are the same sets, they're just listed differently, so you could say, even though we've labeled them differently, you'd say they're equal to each other, even though the order is changed, and that's okay if that happens. Of course, they're nowhere near set A, although it may be the most delicious. So here we go. Let A be these, set A, that would read, set A equal these four numbers, 10, 20, 30, and 40, indicate if the statement is true or false. 15, again, this reads, well, I'll type it out, what the heck. 15, I'm not typing 15, sorry. 15 is an element of set A. I guess in this case we could say question mark. Whatever. Is it a element of set A?
False.
Well, you look at this. I don't see any 15, so I'd say that's false right there. No, I guess to the question mark. Whatever. Another common question we get on this one is 50 an element of set A? No, it is not. And you could, some people have said, well, it has a pattern, so the next number would be 50. It's not showing 50, and it ended the set with this closed fancy bracket, so yeah, it's done. 50 also is not an element of A, so to make that true, there we go. I know the slash was the other way, but I'm left-handed, so that's the way I slash them. Can I say slash in a college setting? E, that's not Euler's constant. Well, I guess it doesn't matter if it is. E is an element of, and this would have a box right there on the assignment for you. So we look at these two, oh, ham and cheese, bacon, LT. Hey, I like both. Heck, I wouldn't mind them together. But E is an element of which of these two sets? And it's possible, I suppose, that it could be both. Again, this would be, on the assignment, you'll see a little box right here. You got to put it in. Well, E is an element of, I only see it in set A, so, well, we'll say set A. I want to say that needs to be capitalized on the homework, but I can't guarantee that it does. I guess that's the important part is that sets are usually indicated or notated with capital letters like we see there. All right, so we got unions and we have intersections as well, okay? So unions would be what we consider or statements. You could say either statements, I guess. That either, yeah. So an example here, we got set A and then set B, and then it gives us these values. Now, if we said we want the set A or B, that's how that reads, we're looking for any elements that are part of set A or B. And I hope that's kind of self-explanatory, but I know that it's kind of not all the time, especially with all the vocabulary we do use in mathematics, but would say, well, what elements are part of set A or B? I see 1 is an element of set A, 3 and 4 and 5 and 7, 9 and 11. And so, well, you say, well, where does the 8 come from? Well, it was or set B. Well, see, there's an 8 in set B, so it is part of this set A or B. Okay. Now you'll notice too that set A has 7 and set B has 7, but we did not list it twice because we don't have to. Okay. Remember, when we're listing these set values, we don't need to list values that repeat. Well, it looks like 11 does too, right? There's 11 there for set A, and there's 11 for set B. Again, we only see it once when we use A or B. Now, that's a union statement or an or statement. The next one is an and statement. That's the intersection. So if you want to draw a Venn diagram and think about it that way, that's fine. But I'm not going to do that. So we can just look at the sets. This is asking what elements are part of set A and B. That's what it's asking right here. And there's the symbol for the and. And so that's it. That reads, find elements that are part of set A and B. Well, like I said, there was a 7 here that was in both set A and B, so we see it in as an element of set A and B, and then we had also 11, right? There's 11. I don't see any other numbers that are part of both, but there's 11 in the AND statement, okay? Well, why did these other ones not show up? Again, that would be because they're not part of both. The AND statement indicates that it should be part of both sets. Can you compare 3 sets? Yes, you can. I just don't think we will in this class. Now, this is sets. Of course, we're going to apply this with inequalities as well. Well, let's keep with the set statements here. So this first one. So this first one, A or B. Okay, so that's the first one we're looking at here. What is an element of set A or B? And I'm going to put these in numerical order. Although, if I remember right, in the homework, it does not require them to be in in order from least to greatest or greatest to least, okay? But I'm going to, just because if it's out of order, it will hurt my brain and I won't be able to get any sleep tonight. So, the first number that I notice is, the lowest one I see is an element of set B, which is 31. Now, this is A or B, so it just has to be one or the other. I see 32s as part of both. That's okay. I'm just not going to list it twice. And then I see 34. Still in the 30s. I don't see any more 30s, but I do see 45 as part of both. And I'm kind of making a little bit of a mental note as I list these. 47, I missed 45, didn't I? Dang it. I'm going to do both, though. And I did say I'd do this in order. So 45 and then 47. And then it looks like 48. That's all the 40s I see. Then I do see a 51. And then finally that's a 1, by the way. 51 and then 60. Sorry, that got kind of small at the end, but I got to close this thing up. That is all the elements of both set A or B. I should say A or B, not both. I mean, they're elements of both, but it's just got to be one or the other. Okay. Oh, let's see. Enter the elements as list. If it was an empty set, it said enter D and E. Okay, well, these are not empty. In fact, the OR statement wasn't. And the AND statement will not be as well because there are elements of both sets. So there's a kind of an S and a 2. I know I've done better fancy brackets, but that's fancy enough. So let's see. What do we got? I got a 32 that matches in both. So let's go and put that in. 32. And then I see these 45s. Remember, I was making kind of a little bit of a mental note if I could remember back that far. And then 47 as well. Okay. I don't see any other matches in both sets. And, some people like to look at it as matches. That's fine. I guess my writing got a little bit bigger to the right. Whatever. Okay. Just don't forget those fancy brackets, right? Because, again, if you don't put these on the exams, I have to take the point. It's 1 point, but it's still 1 point, And that's what I mean. I forgot to read the full problem there at the end. I should have done that at the beginning. I kind of jumped on that one, but I'm just grateful I didn't get anything incorrect there because it looks pretty good. Now, here's our first inequality we see, and this is the first time we're going to apply this AND statement to the inequalities we've seen. Now, it did say the graph. Now, whether it asks for a graph or not, I usually tend to use a graph so I can visually see and check to see where I can find AND statements or intersection between the lines that we're going to be drawing on this, okay? So whether you use them or not is really up to you if it doesn't ask for a graph. Of course, this one does. We're going to graph it one way or the other. Now, it gave me one inequality here. That's a x is less than or equal to 4. It didn't number the line. Here we go. Now, positive to the right, 1, 2, 3, 4. I'll mark it. But I guess you could put more there if you want. Maybe I should have given myself more space. But now to the left, that's negatives, and it's a -5 on the next one. -1, -2, -3, -4, -5. And I tend to mark every fifth mark just a little bit bigger, so I know every fifth mark. It's nice. Well, at least I feel like it's nice. I'm going to start, though, with x is less than or equal to 4. Now, it's less than or equal to 4, so I know it's going to be a closed circle here. Okay, so there's my closed circle. And then, this one is not eating the x. Okay, at least that's the way I do it. Some of you would say it's pointing to the left. All right, whatever. It's the same thing, okay? Now, This would go, if it were its own inequality, would go all the way to the left until negative infinity, all right? Now I'm going to keep that there, even though it may not be part of the final solution. So we'll have to keep that in mind when we get there. The next one, though, is x is greater than, it's just greater than negative 5. So at negative 5 on this number line, I got an open circle. And this one is eating the x, so that would mean it goes to the right. Okay, and I kind of purposely did that line a little bit differently. But we're looking for the intersection. So remember, an and statement, it means that it needs to be true not only just for one, it has to be true for both. So just, again, this is a nice visual because it tells us where they begin to, I guess you could say, collide, intersect, and statement, right? So I can see that starting at here, negative 5, right? In fact, some people would say, look, you get these little intervals right here like this, right? Where we change from inequality to equality for either the inequalities, okay? So starting at negative 5 though, that's you can see anything to the left of 5 is just the 1, but it has to be both. So that anything to the left of negative 5 is no good. So that's where it starts. The question is it going to be a regular parentheses or a bracket on this one? Well, for the interval notation, it has to be true for both. It's not true for this green inequality right here. So since it's not true for one, even though it would make the other one true, it needs to be both. So negative 5, I'm using a parentheses there to indicate that negative 5 would make both of them, well, at least one of them false. That sounds better. Okay. Well, how far to the right does this go? Well, I can see that it would stop here at 4. And again, anything to the right of 4 is just one line, right? You need to see 2 lines there so that it would be part of both. Well, it's not. So it does stop at 4. It's just, is 4 going to end this interval being part of both? Well, yeah, 4 would make this one true, right? If we place x with 4 there, it's true. If I put a 4 in for this x, it's still true. So it's true for both, which indicates that this will be a square bracket right there. Just throw a comma between. Hey, there's our interval. So again, for me, the graph becomes a visual representation of what we should be seeing. Now, you're not going to graph this on the homework. It has to stop, okay? Which means, yeah, well, oh geez, let me get rid of that circle. That on the homework, you got to end the lines like this, okay? Well, what is that going to look like? It should only be one line, okay? So on the computer, when you do this, you can have an open, you can have an open circle at 5. You'd probably drag it to the right, and then at 4, you'd have to put a closed circle. I forget how that's done on the computer, but there is a way. So technically what you see in orange there would be the final answer. Now, I guess I'll go and box that in. I feel better about it now. That's where it begins and ends, and the graph shows every value between negative 5 and 4 would make both of them true statements, yeah. Like you could say, well, 0, right? Hey, 0 is less than 4? Yeah, it is. It's not equal, but it's less. Is 0 greater than negative 5? Yeah, it's true. All right, here's one. You guys try this one. Try this one out. See what you get. So, on this one, x is greater than or equal to negative 1. So, again, the graph will help us. And by the way, just in the future, know that we're going to have to get to this point eventually. They're going to add more stuff to these inequalities. Just use principles of equality to solve them. And the great news is that you don't get to do it just once. Usually you'll get to do it twice, and it's so fun. So, that was sarcastic, no. So that's a 0. Why did I put it over there? Because both numbers are negatives right there. So I'll give myself a little bit more space, right? Negative 1, negative 2. Heck, I'll label it. And then negative 3. There's not much to label here. Okay, so at negative 1, what the heck? I'll do this one in red. So that's it's greater than or equal to negative 1. So that's going to be a closed circle there. And this one is eating the x. So this one will go to the right. And then the next one I'll do in purple. X is less than or equal to negative 3. So again, it's a closed circle there, negative 3. This one's not eating the x, so it goes to the left. Now, for those of you that have had some experience with this stuff, it may throw you off at first. But if you think about this, it has to be an and statement, right? So you could say, what values here are going to make it true for both? Like I see this red graph right here. it's going to make the red inequality true, but it would not make any of these purple ones true. See that? Or the purple line here is going to make the purple one true, but the red one's false. I don't see any intersection at this point. I don't see any and statement that's going to work. So if I wanted to show the empty set, which is what this would be, I guess we'd show these two like this, maybe a D and E on the homework or something like this. But yeah, there's no intersection between these two lines to indicate that any of these values would be true for both. Now, if this was an or statement, that would be very different because it only has to be one or the other. And we'll see some or statements. On this one, if it did ask you to graph it, you just have to leave the graph empty, I guess. Like I showed the red and purple lines here. But really, since it's the empty set, it would just look like a blank line. And it can have numbers, you know what I'm saying? But you wouldn't actually graph anything there. Again, that's a D&E type scenario. All right, graph and give this one an interval notation. And we see that the two inequalities, one is equal to, the other one's not. That's okay. That can happen from time to time. But we're looking for the and statement. So when we look at the graph, we want the intersection. But this one, yeah, we can graph this one. Let's see what it looks like. So I'm not going to do all the tick marks. I hope that's okay. And it may not be proportional. Hopefully that's okay. But I know 3 is positive, so it'll be to the right of 0. 15 is negative, so that's going to be to the left of 0. And it's just farther to the left, right? Correct? Yeah, there we go. So that's all I really need. And I like to show 0 on my number line just so I can see where we start to be positive or negative and then it switches over, right? Kind of like we do with these inequalities. Well, let's go ahead and do x is greater than negative 15. Okay, so that's an open circle at negative 15. It's eating the x. And I have seen students, when they do this by hand, they'll just do kind of a short line with an arrow like this. And then we'll see what happens with the next one, okay? You don't have to. You could have extended that line all the way over like we did on the first one. But this next one, x is greater than or equal to 3. Let's see what this does. So that would be a closed circle at 3, because it's equal to 3, and it's still eating the x. So this one's going to go to the right. Now I do want to extend this red line. Maybe you can do a better one than I did, but that'll work. Okay, but we're looking for the intersection. So where do these two lines begin to intersect? And some of you are like, well, can't you just make them intersect? All right, I don't know if that really helps. It just looks like it gets real sloppy, you know. I'm going to leave it. So where does this begin to intersect? It starts at 3. Well, would 3 make both statements true? Yes, it would. And you can see that it goes through the red line and the purple line too. So yeah, it's included for both. So that's an included element of the set. I'm using square brackets. Well, how far to the right are these going to intersect? As far as I can tell, they both go to infinity, which is never included in the set. But there's our interval notation. So we did graph. Oh, sorry, the graph. The final graph, though, we would not include any of this garbage. Okay, well, I'll do it in a different color. The graph would look like this. That's a closed circle because it includes both, and then goes to the right. Done. So when we go to graph that on the computer, it would mean nothing. Does it mean something when we're looking for the intersection? Yeah, I think it does. But like I said, in the end, you're only going to be looking for this and this, like that. Yeah, sorry, I forgot to close that up. My bad. Yeah, because, again, think about it like this. If it had intersected here, maybe that's negative 10. Maybe this is where this, like a negative 10 right here. Okay, well, then you'd have a maybe closed circle. Then it goes here. Well, then it would have been negative 10 here instead of a 3. This now changes to an or statement. All right, so it only has to be one or the other. And again, the graph that we saw earlier. So this inequality that we saw earlier, when this was an and statement, it was empty because there's no intersection between the two lines. This as an or statement is fine. There's elements to the set because they don't have to intersect anymore, okay? In fact, most of the or statements you'll see, most of them, they'll generally go in opposite directions like this, and there will be no intersection. So what does it mean if they intersect? We'll get there. We'll get there. Okay, but for this one, well, I guess I don't really need that example anymore because we're going to see this one. So I'm going to get rid of it. But let's start here. We got the graph, and we do want the interval notation, so we'll do it. But I will start with this first one. I'll do it in red. Oh, I need to put some numbers on there, right? So there's 0. I'll put 5 about right here, and then, 12 somewhere around this area. Sorry, again, that's not proportional, but the proportionality thing doesn't bother me. Sorry if it does you. In any case, 5. X is less than 5, so that's an open circle. It's not equal to 5, just an open circle of 5. This one is not eating the x, so that line would go to the left. Okay, so again, some students would choose to shorten that up just in case they do intersect somewhere, whatever. Okay, now I will do the next one in purple. That's x is greater than or equal to 12. Since it's equal to 12, it could be equal to 12. I got a closed circle there. This one, though, is eating the x, so that's going to push the line to the right. Okay. Now again, this looks exactly like the one that we saw 2 examples ago, right, with the and statement, but the or statement's okay. It only has to be one or the other, and we will unite these with a nice union statement right there. I think some of you would prefer the U look like that. Whatever, all right. I'm just going to do a curved U. I mean, I like the other one too, don't get me wrong, but let's do this red line, okay? Let's do the interval for this red line, which if you look at what we've seen, you could pretty much ignore this right now. We're just going to do one line at a time. So how far does that red line go to the left? Well, it goes to negative infinity, but we can see it stops at 5, which is not included because it's an open circle. I already have my or statement built in. If you didn't have it before, put it in there because you're going to need this or statement or the union statement. And then the purple line there starts at 12. It's a closed circle, so it's included, and this will go all the way to infinity. Well, that's a lot of values. Yeah, well, in an infinite number of values is a lot of values, but we got two different parts. Now, this means also that if you put in, let's look at an example, like 0 here, okay? 0, it only makes this one true, this one in red, true. It does not make this one true. It doesn't have to make both true. It only has to make one true, one or the other. So what values make this both not true? Well, see this one, we'll say 10, right? 10 is an easy number to work with, right here, around there. Well, 10 is not less than 5, so that's false. 10 is not greater than or equal to 12, so that's false. See, these values in between 5 and 12 would make both statements false. And you could say, well, 5 makes it false. Yeah, but that's where this inequality here transitions from being true to being false. And so that's the equal part of it. We need to know those equalities as well. So x is less than 40 or x is greater than or equal to 32. All right, some big numbers, no problem. Put 0 over here. Here's 32. Here's 40. I deliberately push those really far apart because I don't really care. And I really hope that you don't, but if you do, you can make it a little bit more proportional. If you want to put 40 marks on the line, you're free to do that. I'm not going to do it, so sorry. In any case, x is less than 40, right? Okay, well, here's an open circle at 40. I'll try to make it the same color here. Open circle at 40 going to the left. And I made this one a little bit short on purpose. The next one, x is greater than or equal to 32. So there's my 32. I put that on the line. It's a closed circle there, and this one goes to the right. See here? Let's extend these lines. Okay, let's see what this looks like. Well, this one goes as far to the left. The red one goes as far to the left as possible. The purple one goes as far to the right as possible. This is an or statement, which is important to know, because how far to the left does this go? It would go all the way to negative infinity. How far to the right does it go? Some people would say it stops at 32 here. No, you could get on this red track, jump on the purple one here. You could jump back and forth in between. But once you get to 40, you got to jump on the purple one and go all the way to infinity. I know some of you guys are thinking and beyond, but whatever. Okay, so there's our interval. And so the graph, the final graph actually, let's start with a new line, although it may not be a straight. You just need a full. I'll use a different color. Sorry about that. It's got to span the whole line on this. And again, on Canvas, you're going to need to see these arrows there. Otherwise, it thinks you want to stop at a certain point. More hypotheticals, right? We could say if this was an and statement, it would only be between 32 and 40. But since it's an or statement, it goes forever. Yeah. So this one, let's do this one though, okay? So this one, I know there's some work to do in this, and some of it's purposeful work. You guys try this one out, okay? Try this one out, then we'll go over it. So a little bit of a spoiler alert. I'm going to put the 0 there. That's on purpose. But let's solve these, okay? So the first one, I'll do in red, and hopefully make this look nice. But to solve this one, you're gonna have to divide both sides by 3, right? And make that a phantom 1. X now is less than negative 15 divided by 3 is negative 5, okay? So X is less than negative 5. And some students, again, just on what we talked about in 2.1, some students would have flipped that inequality, but the coefficient was not negative. So we don't have to worry about flipping that inequality. It was a constant negative 15. So let's go to the graph and we'll just put this part of the graph on there. Okay, so negative 1, negative 2, negative 3, negative 4, there's negative 5. Okay. All right, well, that'd be an open circle at negative 5. This one does not eat the x, which means it goes to the left. Okay. Now I will solve the next inequality, so that would be divide both sides by negative 5. This one will flip the inequality, okay? So that's a phantom 1 now, x. Yeah, we're going to flip that inequality to make it less than or equal to now negative 2. So at negative 2, right here, I now have a closed circle. This one is not eating the x either, so this one also goes to the left. Now you'll notice an intersection, but with or statements, intersections don't mean anything, okay? For the interval, okay, let's say, where does this go? How far to the left does this go? Well, we know this one, both of them actually go to negative infinity. Now, it would follow the lines, either one of them, over here, and then some of you'd say, well, it stops at negative 5, right? No, this is an or statement, so it can jump from one to the other. So you could say it's on the red, I'm going to call it a red track, because I like trains. But then it's going to skip over to the red one, the purple one, boom, it's going to follow that all the way to negative 2, and that's where the line ends. So this one actually goes all the way to negative 2. You know, I'm going to put it closer to the interval. It goes all the way to negative 2, which is included. So that would be, this would be the interval right there, okay? And what does that mean for the graph then? Well, that means that you need to get rid of this part right here. And of course, on the graph, you're only going to graph one of these. Starting at negative 2, you're going to drag that line to the left. So you see that arrow, boom, you're done. I apologize, I forgot one thing on my inequalities. I should have put an or there. Now, do keep this in mind. If we just change this to an and statement, I know this is hypothetical again, but if this was an and statement, it would have ended at negative 5, because that's where the two lines would have began to intersect. And it would have, well, since this one does not include 5, it would have been a closed parentheses like that, okay? All right, here we go. We got this graph, and it says, hey, look, this is going to result in this purple one, okay? So it's not giving us the inequalities. What is it? Oh, the following graph shows this too, the red and the blue, which result in purple. That seems like it's very nice, right? Because red and blue make purple. Is this an intersection or union? Well, and remember, an intersection is an and statement. A union is an or statement, okay? Is it an and statement or an or statement? Well, if it were an and statement, it would be confined within the intersection of the two lines. But since it resulted in something that spans all the way across, this has to be an or statement, or, well, I guess you could say union statement here. Boom. I'll tell you, I don't really care for this notation here, because remember we said it should show arrows on the ends?
Right.
It won't show that on Canvas if it shows this. Now a quick hypothetical here is, what if it just showed the line between negative 3 and negative 4? See, then it would be the and statement where the two lines intersect.
Okay.